So the idea here is that, yes, it was all accidents that just got selected by the environment, at random, you might say. But because there's been such a long period of human, or not human history, of the history of the Earth, there was a lot of time. So if you look at this chart here, there's no life for the first billion years, scientists imagine right now. Let's say the Earth is about 5 billion years old, the way scientists now think. There was no life for the first billion years. Then there was something that was sort of moving in that direction, a bit like what was discussed in that video we just saw. Then, for most of the history of the Earth, there was life that we would hardly recognize. Microscopic, single cell, nothing too interesting, no brains, no communication systems. Towards the end, a little bit of sexual reproduction coming in, but really life that we're not that interested in, and it still exists, a lot of this kind of life on Earth today, but it doesn't seem that interesting or obvious to us. Largely, it's microscopic, for one thing. But that was billions of years. Most of history of the Earth, according to science, was that life. Then something happened and life started complexifying, and something happened to create sexual reproduction, and things took off. And then in here, in the last, let's say billion years, you've got fish and fungi and underwater plants and trilobites, if you ever studied those in school, little creatures that lived under the water and were kind of like beetle-looking things and so on. And then, in the last, let's say, 500 million years at most, you start getting life on land, you get dinosaurs, and then quickly after the dinosaurs, really, on this scale, you get mammals, and then eventually primates and humans. So the idea is that there was so much time for mutation to occur and be selected and for things to get complex, that all you need is a lot of time, and it can be random like this. Gradually, things complexify just by accident. That's the idea of evolutionary theory, and sometimes when people start taking a closer look at it, they maybe come in here thinking that it was true, and now they're sort of wondering. It does kind of beggar the imagination. It's difficult to imagine this happening like this by accident. So, how many people in here learned about natural selection in high school? 1, 2, 3, 4, 5, 6, 7, 8. How many people learned about some like creationism? Anybody learn a creation theory? Went to 1, 2, 3. Anybody learn both? 1. Anybody learn intelligent design? You did? Interesting. Okay, well, maybe you can tell us more about it. I've never taken a class that was taught from the point of view of intelligent design before, so. Sorry? Okay. Okay, so we're going to have a break in a minute, but before I get to the end of this part, I just want to go over some of the common misconceptions that I think people have about natural selection and that I want to try to address, okay? The first one is you've probably heard this phrase, the survival of the fittest. And often people think in terms of somebody being really strong or really scary or the opposite of what I am, right? That, really fit, right? And really kind of dangerous and so on. But that's not what the idea of fitness is in the theory of natural selection. The idea of fitness in the theory of natural selection is that something fits into its environment, okay? It can fit into its environment in such a way that it lives long enough to reproduce. That's what makes it fit in its environment. And really that's all that's important, because the theory of natural selection is entirely about reproduction. The theory of natural selection is about surviving long enough to reproduce. After that, it doesn't care whether you've got 3 eyes or you're 4 feet tall or whatever. If you can reproduce, you're fit, and if you can't reproduce, you're not fit. Is that clear? Because I don't want anybody coming in and saying anything about fitness being about being strong and scary, or that the idea of natural selection is the strong ones survive. Okay? It could be in the future. Well, I'll get to that in a minute. Okay. The second is the idea of optimization. If you believe in the theory of natural selection, then we are not optimized. We are not the best thing that we could be, and neither is any other species. We're the best thing that came up randomly through mutation. And if you think about this, there's some argument for this, I think, that, why do women have periods? Why do we have an appendix? The eye could be made better than it is. Why isn't it? We're not optimized. That would be an argument that people would make for this theory. That in fact, what happened was mutations occurred, and they might have carried some negative things along with them too, but they carried the most positive attributes as well, so they were selected by the environment to survive and reproduce. Does that make sense? You following me on this idea of optimization? Because again, a lot of people have thought, well, if we're at the end of history, then we're optimized. We're the best that it could be. And there were people in the 19th century after Darwin came out, they believed in something called social Darwinism, and they thought, well, we can make better people. That's what the Nazis thought, right? We can make a master race of better people because we know what natural selection wants, and it wants the fittest and so forth. But in fact, if you survive and reproduce, you're just as fit as anybody else that survives and reproduces. That's what fitness is. So there's nothing unfit from a natural selection point of view about being a Jew or being lame or having one leg or anything, because if you can reproduce, you're fit. And again, we are not optimized. We are not, so those who think that we've been designed, and we'll hear more about them in the second half, have to come up for an explanation for why we have appendices. Yeah?
But if natural selection has very specifically to do with the individual or the organism or whatever to its surroundings, are we optimized because we're finally changing the surroundings that we're living in?
Well, I'm very glad you brought that up. Are we doing the humanity suicidal in here?
Yeah.
Okay, well then I won't get too far into it today, but when we get back to is humanity suicidal, that's really what that essay is about, and whether or not we're even fit for our environment anymore, right? The idea would be that when we were hunter-gatherers in Africa 10,000 years ago or 20,000 years ago or whatever, then having all this intelligence and being very self-interested and so on was naturally fit for our environment. But in fact, we're destroying our environment. So, I mean, there'll be more to be said about that. I won't anticipate. Okay, another thing is predicting the future. Again, and this is going to bring me to my final point too, about how scientific this whole theory is actually. But the fact is that the environment is so complex that I don't think we can really see into the future and imagine what will be fitter in the future. So again, is there any value in the theory of natural selection for predictive technology and so forth? And it's an important question because we're quickly going to be leaving soon the world of natural selection. And we're going to have a world where we do artificial selection, genetic engineering and so forth, right? And when that world comes, people are going to think, well, I know that this will be fitter if everybody has, is a foot taller than they are now, or something like that, or whatever it might be, or a foot shorter, right? Because they won't eat as much, or, But we don't know what the environment of the future is going to be, so we can't really know what will be more fit in that environment in the future. And to have that kind of map of the future so that we did understand the entire environment, and this kind of comes back to the question he was asking and the question about is humanity suicidal, but to have that kind of information it would be to know the future essentially, because it's not something you can just map, it's something you would have to know everything that was going to happen in the future in order to know what would make us more fit. So in many ways the theory might be kind of empty, the theory of natural selection, at least from a technological point of view. Genetics is another matter, but the idea of natural selection is basically saying the environment lets something last longer than something else, and that'll always be true. But it doesn't really give us anything to work with. It doesn't tell us where we came from, and it doesn't tell us where we should go. So the final one I'm going to mention before the break is, can we really know about the past? Or in a sense, is arguing that the world began the way that British fellow was talking, or that we know, how old something is, or that we know that God didn't create the earth, that it happened this way, or that God didn't create animals, it happened this way, and so on. Our evolutionary theory is really falsifiable when they're talking about the past. We can test evolutionary theory now to see whether it works. We can test the theory of natural selection now in the present. But is there any way for us to actually be able to falsify theories about what happened in the past? So the question, and it comes back to what Newton said about science last week, if you remember, that science is really about, it's very pragmatic in a lot of ways, and it's about what you can do now and what you can prove or disprove now, by which I mean falsify or not falsify now. And in a sense, maybe it's not scientific to make claims for what happened 5 billion years ago, and maybe we'll never know scientifically what happened then. There'll be a theory that we all are pretty happy with, at best. So if you don't believe in religion and you have science, yes?